These terms here, don't copy it just yet. We'll talk about what these terminologies are, but what you need to understand is the graph first. Then all this will make sense. Okay, so at this point, this is the terminologies that you will use, that you are required to understand, but there's no point trying to learn it right now if you don't understand what, 2 pi divided by n, what is it really doing? Why is it 2 pi divided by n? What is the amplitude? What does that mean? Why is it negative a to a? All of that will be answered once you understand the unit circle. Okay, then all this makes sense. Okay, but for now, ignore this. What I want you to understand though is this. We're going to start off with the first function. We're going to call it sine. Now, just like any function you've learnt, okay, any function. So let's go back, just a bit of a recap. You know how you learn normally x squared, that's your quadratic. You learnt that in year 9. And then when you came and you saw me, what I did was I tried to expand that. I tried to teach you transformations. I taught you y equals to a times bx plus c all squared plus d. Yeah? That's what I tried to describe. I said whatever you're doing to x, you're squaring it. So this is whatever you're doing to x is being squared. Whatever you're multiplying to the function is your a. And whatever you're adding on or subtracting is your d. And that tells you up, down, left, right, thin, wide. Yeah? And the same thing with exponentials and logarithms. When you start off, it was y equals 2 to the power of x. And then I gave you a transformation equation. I said y equals 2. And you had a times, this could be, I'll keep it as 2. But then bx plus c plus d. It's the same thing. Whatever you're changing to x, so that's my x there. Whatever I'm changing to x makes it left or right, up or down. And a dilation means thin or wide. It's still the same thing. So you had your reflection in your x-axis, a reflection in your y-axis. It means for sine graphs now, it's exactly the same thing. So what you start off with was, we said sine of an angle, we said sine theta equals to the y values, right? Well, now we're going to change that. We're just going to change the variables. It will now be y equals to sine of x. Just like how you've been learning over there. That's what we start off with, right? That's your basic function. What I'm giving you today is I'm going to give you now the transformation equation. Okay, so this is the transformation equation for quadratics. This is the transformation equation for exponentials. Then for the sine graph, it's the same thing. Y equals... Yes, of course. So a times sine of bx plus c plus d. Same concept. So that means... Whoops, I just try to fix that part there. Yeah. There's different letters, but N is your B, T is your X. Okay? So if you like, ignore that. Start it from here, if that makes more sense. So I'm trying to relate them all together for you. Yeah? So quadratics, then you learned transformations. Exponentials, you learned transformations. Now, I'm trying to teach you sine graph. So you want to know what sine is. I said it's the y values. Well, what happens if I change the angle? So x is now the angle. What if I change the angle going from 0 degrees to 20 degrees to 30 degrees, 40 degrees? What does this graph look like? Okay? And I've changed it now to these transformations, and they follow the same thing. Plus d will tell you if it goes up or down. A will tell you it makes it thinner or wider. Bx plus c, if you make that equal to 0, it will move left or right. Same theory. I haven't changed any of the theories. It's all the same. Yeah? What we're going to try to describe in each one, and all those terms that you'll understand as once I show you the graph and everything. Okay, but for now, this is what I want you to copy down. And underneath that, whatever you remember in terms of the transformations, again, I'll write it again. This is what I want you to write. Plus d means up or down. So plus goes up, minus goes down. A is still the same thing. It's a dilation, means stretching from the x-axis, so it's stretching vertically. You're playing around with the y values. You make it thinner or wider vertically. Yeah? And it also has a reflection. So because you're playing with your y values, it's reflection in your x-axis, because y can go positive on the top or bottom. So it's moving up and down. Because it's moving up and down, it's a reflection in the x-axis. Okay, reflection in x. Same thing with bx plus c, the technique I've always taught you. I said bx plus c, let it equal to 0, solve for x. If it's positive, it moves right. If it's negative, it moves left. Okay? And then finally, B, which is being multiplied to X, B is your reflection or stretch. So just be careful there. B, reflection in your Y values. Oh, sorry, in X values, but in your Y axis, reflection in Y axis. And it's a dilation, which means stretch horizontally. So from the Y axis. So if you think about the Y axis, if you were stretching, moving away from the Y axis, it's stretching horizontally. This is stretching vertically. And I'll show you in a graph later so you can see how playing around with each and every one of these letters will change the graph. And everything I taught here is exactly the way I taught for quadratics and for exponentials and logs and cubics. They're all the same way. Square root functions, everything I've taught is the same thing. Okay? Once you copy that down, we're going to move on to looking at the graph and why the graph looks the way it does. Okay? Once you know the shape, sketching it will be easy. Okay? Let me know when you've copied those, just those transformations. And I'll show you how we're going back to the unit circle again. Everything goes back to the unit circle. Everything. Which one? In Y-axis. Before, I reckon. I'll finish before. All right. Copied? Yes. All right. Here we go. Now, let's just do a bit of a recap. Let's do a quick recap. Remember unit circle? Here we go, unit circle. If I pick a coordinate around the circle, remember everything goes back to the circle. Every coordinate is on the circle here, so it moves in this sort of motion. We said in a unit circle, you have a maximum radius of 1, -1, 1, -1. True? So, if we're talking about sine now, you told me sine is your y values. So, I'm just changing x now. Instead of theta, I'm calling it x. X is your angle. So if I change x to 30 degrees, then it'll be sine of 30, which just basically means, what is the height when x is 30? So what is that height? Okay? Now logically, if I were to draw a graph now, on a logical basis, if I said starting from 0 degrees to 360 degrees, starting at 0, so this is x-axis, these are my y values. Starting at 0, when it's 0 degrees, which is here, what's my y value at that point? 0, because you're looking at the y value, that's sitting at 1, 0. So the y value is 0. So it makes sense my first coordinate starts here.
What did you draw next to it?
I drew the dot here. Yeah. Okay, so I said when it's 0, when a y value is 0, y value. Just keep thinking about y's. Y value, yeah? Y value. As I increase the dot, so as I move the dot, which I'm going to highlight in yellow so you can see, as I move the dot, what you're seeing is the y values increase. True? They're getting larger and larger and larger and larger until you reach a maximum height of 1. Where? Where does it reach 1? At 90 degrees. True? So at 90 degrees, right up here, right up there, at 90 degrees, you've got a maximum y value of 1. So, what does that mean? If I'm saying 1, that means I've got a minimum height of 1. I've got a minimum height of 1, and I reach at 90 degrees, I should reach my maximum, which is 1. So reach there at 1. As you head forward, your y values start to drop down. Look at the y values, they're reducing. You see how it's getting smaller? Not yet, yes, but it'll be similar. It's reducing. It's reducing and reducing until you reach angle pi, which is 180 degrees. At 180 degrees, your y value now again So the y value, if you're just thinking about the Cartesian plane, the coordinate right here is -1, 0. So your y value is 0. So that makes sense that 180 degrees, you're now back at 0. At 0. So right now my graph, it increases steadily, it increases and it reaches the top, which is the maximum 1, and it decreases steadily until I reach 0. Yep. Okay, cool. All right, so it reaches at 180 degrees. Now from here, what we can see is the y values now get larger and larger, but it's getting larger in the negative direction. So these y values are getting larger, but increasing to a maximum of -1. So at 270 degrees, you can see here, once you go around all the way here, so I'm started here, 0, I'm moving around, that's 90, 180 degrees, but when I reach 270 degrees, the y value is a maximum of -1. Okay, so it reaches a -1. So that means at 270 degrees, I reach -1. And then as I go from 270 degrees to 360 degrees, 1 revolution, you can see the y values. Think about the y values, they're getting smaller. Every y value is getting smaller and smaller and smaller until you get to a y value of 0. The x value is 1, yes, but the y value is 0. So this graph here that I just roughly drew, this is the sine graph. Sine of x graph, that's 1 revolution. Okay, this is the 1 revolution, 0 to 360 degrees, it's 1 revolution. That means now, when you play around with the graph, put an A, it makes it thinner. Put a B, you also make it thinner. You put a negative, it flips it. You can read it all now. If I put a +1, it just moves the graph up by 1. Okay, so everything stays the same, it's just a revolution. Now, I'm going to play with GeoGebra just so you can see the sine graph and the cosine graph. They're 2 different exercises. If you understand the unit circle, technically you can already picture the 2 graphs already. Okay, so let's have a look at GeoGebra. What I want you to see, this is a unit circle. Okay, what I want to do is I'm going to move the coordinates around the circle. As it moves around, I'm just going to sketch the sine graph. Meaning you're going to look at the y values as it increases and how it sketches in the graph. Okay, so watch. When I change, I put on a sine graph, I'll put on a trace so you can see. So starting at this coordinate 1, 0. So if I just zoom in so you can see that's 1, 0 there. If I increase the angle, so I'm increasing the angle, what I want you to see, what's in red. So what is in red here is the height. That's the height, that's the y value. So at that point, I've got a y value right here. That's about 0.33, that's what it says here. Okay, so it's 0.33, that's my height. So it's increasing, my y value is increasing. So that's the height, height's increasing. Okay, now, I'm going to move this point, I'm going to keep moving until I reach 90 degrees. Now we predicted when it reaches 90 degrees, it should reach a maximum height of 1, which is true. See, from here, as I increase it, when I reach this point of the unit circle, what's my y value? My y value is 1, which makes sense. At 90 degrees, which is pi on 2, I reach a maximum of 1. See, once I start moving the unit circle, as I move around here, the y values decrease until it reaches 0. Where does it reach 0? This is pi on 2, pi. That there is pi. So at pi, when it reaches pi, I'm expecting it to reach back to 0 again. Yes, ma'am?
Is cosine the opposite? So it goes...
No, cosine is the x value, which I'll show you later, and it's the x value. So you look at the x values. What happens when you move around the circle? What happens with the x values? Yeah?
Oh, it's going to go up. It's going to be... I got to go both ways.
Okay. All right, sure. Yeah. Now, if you watch as I increase my angle, and I keep going until I reach 180 degrees, see, it makes sense. My y values decrease, and y values decrease until it reaches 0. Okay? And then after that, if you just look at the y, it's all about the y values. Everything that you're sketching right now is just the y value and the angle. As I increase my angle towards 270 degrees, you see that red line? This is just describing the y values. So the y value at this angle, I have negative whatever, that's what that's representing. at that point, that angle has this height. So it's a negative y value. So you can see at 270 degrees, which is 3 pi on 2. See, once I reach 3 pi on 2, it's a maximum y value of negative 1, which explains why this stops at negative 1 at 3 pi on 2. Okay? And if you continue, if you continue it, it now becomes 0. And this right there is your graph of a sine graph.
Can you do a cosine graph quickly just so I can see the cosine, please?
Yep. So now you're going to look at your x values. I want you to look at your x values. And I want you to think why it looks like that. Again, see, starting at 0, what is your x value? It's 1. So it starts here. When x is 0, the angle 0, it's 1. But x decreases as I move around the circle. See, from here to here, x is decreasing, which is why it's decreasing. But when x reaches pi on 2, which is 90 degrees, x is 0. The x value here, the x value of that is 0.
It's just been moved back.
Yes, they're complementary angles. Okay, so you can see as I move all the way up until, actually I'll untrace it all. I'll just go back here. Okay, here we go. So we watch cosine as I move the angle. I start at 1. And as I increase to 90 degrees, you see x values are decreasing. See that dot there? This is what x is. That's your cosine. Cosine will decrease. Hence this is decreasing. Okay, it decreases up until you reach 90 degrees. See, when you reach 90 degrees, which is here, see the coordinate here, 90 degrees, my x value is now 0. Which is why at pi on 2, it's 0. So what can you predict when we move this way? See, my x values now are increasing. But what are they increasing? It's increasing in the negative direction. See, x gets larger and larger and larger in the negative direction up until you get to negative 1. It's a maximum distance. The x values become negative 1. Once I reach over here, x values are negative 1. So after 180 degrees, you should reach negative 1. Where's negative 1 on this Cartesian plane? Negative 1's here. So I'm expecting at pi, it should be negative 1, which is over there. So if I continue, second half, if I could do that other quarter, see that? See that blue line? That blue line is representing what my x value should be. And that's almost the maximum distance of negative 1, and that's what it's representing. And that's almost the maximum distance of negative 1. That's what this is representing. Okay? And then you can predict as I move back, it means x is going to get smaller and smaller and smaller until it reaches 0. It's all the x values. Ignore the y values. You're just looking at the function x. And that's the confusing part. That's what I was trying to say. If you've got your symmetry properties, you can work with it and start to see how every x value is graphed as you're moving around the circle. Because it's just the x values and the angle. That's all you're focusing on right now. Okay, so as I increase this, you can see as I increase the angle, moving around the circle, the x values decrease. That blue dot is decreasing. It's moving and moving. The x values are getting smaller and smaller and smaller, which is what's shown. In fact, it's getting smaller and smaller and smaller and smaller until I reach 0. So these dots here are representing my x values. Okay. It's contradictory because this is your y-axis. The y-axis represents your x values. Yeah.
Mr. Trout, got any animation to show this?
Oh, that's cool.
Yeah. This represents how the values differ.
Oh. Is that GeoGebra?
That's not GeoGebra, that's someone making it just put it there.
Send that to me.
That's
Okay. If you can email it to me or something like that, that'll be great. Otherwise, this is one way to sort of seeing it. Okay. Now, the reason why I just wanted to show you this part is just so that you can see the shape of the graph. Now, even if you didn't understand that, I prefer that you do, because that means when you answer the questions and you solve for the graphs, it makes a lot of sense what you're doing. So, this is what we've learned so far. We've got a sine graph. We know how to transform it. Let's go back and read the terminologies now. Okay, so let's think about terminologies. Period is 2 pi divided by n. See, a lot of us, we don't understand, well, what is the period and why is it 2 pi divided by n? It makes a lot of sense here. 2 pi is 1 revolution. So it takes 1 revolution. How long does it take to make 1 cycle? Okay, and we know that to make 1 circle, a unit circle, is 2 pi distance. This is your graph. That is 2 pi. Now I did say that you can stretch this graph horizontally, or you can stretch it vertically. So that means I can shrink this graph half the amount. I can shrink this graph if I wanted to by half the amount. So that means to make 1 revolution, I can do it in pi. Okay, I can make a small circle and do a revolution in pi distance. And that's where, how we know in terms of dilation, we can actually work out it's 2 pi divided by the number of times you're going to halve it, or triple it, or quarter it. That's why it's 2 pi and n. Okay, so let's have a look at what I mean. I'm going to go to GeoGebra, and I'm going to do an equation so you can see what I mean when I change the b term and why it's 2 pi and n. Okay, let's have a look. I'm going to use normal equation. I'm going to call it y equals 2, oh sorry, f of x equals 2, a times sine of b times x plus c plus d. Yeah, that's exactly how I taught you this is a general equation. I'm going to create my slides. So this is my graph. Okay, it's going on infinitely, right? Actually, maybe I'll make it, I'll ignore that one. Let's do g of x, wait, function.
This is how the cycle is solved.
All right, here we go. Let's do c as 0. All right, here we go. Let's have a look at this. Alright, year 11s, final thing. Just a final thing for today. Here we go. So we got a sine graph. Yeah? It's from 0 to 2 pi right now, meaning 0 to 360 degrees, 1 revolution. This is the graph of your normal y equals sine of x. I haven't added plus d or anything. But if I want a plus d, means it should lift it up or down. Yeah, so if I change the equation by changing d, see if I move it up, plus 2, see I want you to look at the equation. The equation is the important part. Plus 2, that's what I taught you. Plus 2 up, and you can see it shifts up the graph by 2. If I minus it, it goes down. See, it's minus 1.5, it goes down. See, so if I put it back at 0, everything starts at 0, and if I minus by 1, that point there should go down to -1. So if I do that, see, I want you to see, if I do this -1, I change it to -1, it goes down to -1. So that makes sense. Yeah, so this is your graph. When you change that d, it just goes up, down. Yeah? Now, I mentioned about the period. The period, this is called the period. It's how long it takes to make 1 cycle. So 1 revolution around the unit circle. Now, if I change that b term, and this is what I want you to see. I'm going to change this back to 0. Look at b. If I change that to 2 now, you have now in the same distance, 0 to 2 pi, 0 to 360 degrees, I now have 2 revolutions. See, this is one revolution. From 0 to pi. And then from pi to 2 pi, it's another revolution. Why is that? See, when you have a 2 there, that means you're stretching it. You're stretching it either away from the x-axis or from the, away from the y-axis. When you put a 2, technically you're halving it. So initially you had 1. You're halving it now. So because you're halving it, this is 1 cycle. Instead of being 2, instead of 1 nice whole one, you've halved it. That's why you've got 2. 2 of them in 1. So that 2 there is responsible for the number of cycles or the period. So initially it was 2 pi, but by putting that 2 there, you've now changed the period to 1 pi. Okay, so this is what I'm trying to say. This is what I'm trying to show to you. What you're used to seeing is a unit circle goes 0, pi on 2, pi, 3 pi on 2 to 2 pi. You're used to seeing it as y equals sine of x. We know that it goes like this. It goes up, it comes back down. That's 1 cycle, right? But what they've done now, when you put that 2 there, you're actually shrinking the graph by half. So that value instead of 2 pi, it now shrinks back here. That's why you get your blue graph, which goes from here to here. That's 1 cycle now. So what does that mean for the unit circle? Your unit circle changes. It now becomes 0. Instead of pi and 2, it's pi and 4. This is pi and 2. This is 3 pi and 4. This is pi. That's the difference between the two. See, when you put that 2 in, it was 2 pi to make 1 revolution. Now, it takes pi to make 1 revolution. That's why when they said the formula for the period, they said the period is equal to 2 pi. So the number of, how long it is, how many times are you dividing it? You're dividing it by 2. So if you divide it by 2, then it makes it pi. Period is 1 pi. If you're shrinking it by 3, it'll be 2 pi and 3. So watch, if I change that to a 3 now, if I change that value to a 3, you should see 2/3 of a graph. 2/3 of a graph to make 1 cycle. So 3. See, this is 1, 2, and over here, you're passing over there, that's 2/3. It's 3 there, but there's still that 1/3 that's missing. Okay? So that's what it's doing. If I change it to 4, what you're actually doing is you're saying quarter it. Shrink the graph by a quarter. Wait, I'm trying to make that point.
You never get it.
I just had it. So make me laugh. Oh my god. I had enough of this. Here we go. So what I want you to see, from 0 to 2 pi, I should have now 4 cycles because I shrunk the graph by 4, so it's quartered now. So instead of 1 cycle before, I shrunk it down by a quarter. So you can see this is 1, 2, 3, 4. So that's why we say, when you say 2 pi on n, 2 pi on n, this is what you're really saying. You got a period, 2 pi divided by 4. That just tells you to make 1 cycle, it takes pi and 2, which makes sense. This is pi and 2. Pi and 2 is like half of 3 point something, so that's 1.5. That makes sense. See, 3 point something, half of that makes sense. And when you say it's 2 pi on 4, or 2 pi on n, that's what the period means. The period is just a cycle. Okay, so if we go back to...
So 2 pi on n just means something like within 2 pi, how many circles?
Yes. It's the number of cycles that you have. And that's dilation. The reason why it happens, because n is the value times into x. Okay, so if that's t, n is the responsible number that dilates it. That's why. In my case, I called it b.
Wait. If b is 2, they're gonna be 2 circles.
Yes, between 0 to 2 pi.
3 to 3, 4.
Yeah. Okay? So just think of it as shrinking. That's what the b term is. Amplitude is your new term that you need to understand. Amplitude is how much you're stretching it. Now remember the graph has a maximum value of 1 to negative 1. So amplitude is based on the number of times into sine function. So if I put a 2 there, if I put a 2 in front of the sine, so if I put a 2 here, what does that mean? That just means double it, stretch it by doubling it vertically. So it means stretch all the y values. So if I stretch all the y values right now, instead of 1, I will now have 2 and negative 2. Okay, so watch. I'm going to change that equation. I'm going to go back to GeoGebra. I'm going to change this back to 1 again. And then watch. If I change a to 2, so what I want you to see is, what is it doing? It's just dilating it, or stretch. Oh my god. You know what? I'm going to change it to 0.25 again. I just want you to see how everything I've been teaching you is the same thing. It's the same dilation. So, you see, initially it was 1, but by putting the 2 in front of it, you're stretching it vertically. All the x values are still the same. That's still 0, pi, 2 pi. That hasn't changed. It's your y values that change. So what's an amplitude? The name for the amplitude is just talking about this. From here to here is 2, and that 2 is that value there. Oh yeah, true. It's pretty good. Yeah. Okay. So in terms of terminologies, let's recap what I just said. A, I told you it makes it thinner or wider, but because this has a cap on the top and the bottom, we call that the amplitude, which makes it thinner or wider. That's what 2 represents. Okay, so 2 just represents the thinner or wider. If I make it a negative, it's a reflection. Reflection in x-axis. So if I change that to a negative 2, say negative 2, it's just reflection. You're just flipping it. All the positive values become negative. All the negatives become positive. Yeah? That's why there's a negative 2 there. But it's still an amplitude. From here to here is still 2. You stretched it vertically. Okay, and then finally, C and B just moves it left and right. So you can see it's just moving left and right. But because I restricted the graph only between 0 to 2 pi, that's why you don't see that sort of movement. Okay, but you're really just moving it left and right. So you're left, right. How do we feel? Yes, it's quite a bit to take in. That's why I'm going to take 2 sessions on this. But what I wanted you to see is you didn't have to memorize these. Amplitude is the A value. Stretch vertically. Period is the stretch horizontally. So it's 2 pi divided by n, because 2 pi is what we normally start off with. 2 pi is your normal 1 revolution. Domain, well obviously, a circle you can do many revolutions, so it's R revolutions. You can have many infinite revolutions, that's why your domain is infinite. And then range, your y values, it makes sense. The y value was from -1 to 1 for every one of them. That's why it depends on whatever a value is, whatever that a is, that changes your maximum height, maximum or minimum value. Okay, so you don't have to memorize all this. It all comes from your unit circle. I'm going to try to reiterate that in the next lesson again, but it's the same thing. That's why I'm trying to get your head around, trying to understand the unit circle from those terminologies. Okay, so going back to this graph again, changing, doesn't matter what you change A, so if I change it to 4, you see it just changes the graph. Wait, I would just make this 0. 0. See, all it does is it stretches it. So your maximum value is now at 5, minimum value is at 5. That's what that was trying to say, the range. In terms of your domain, so remember your actual graph should be this. That's your normal graph. Infinite revolutions. Doesn't matter how many times you do a revolution, it's meant to go infinitely. That's why your domain is all real values. Okay? Now I know that's a lot to take in terms of language, terminology, so I'm going to do it again next session, but I want you to keep in mind the shape of the graph for a cosine bases itself from the x values, the sine graph bases itself from the y values. You get that? Everything makes sense. Okay? And that's the hardest part to take in. Okay? That's why I said this is the hardest topic to take in, but if you're at least getting what I'm saying, it's fantastic. It's really good. Okay? We'll do the exercise tomorrow, so no homework for tonight. Just go home, think about it. Just think about what I'm trying to say. Unit circle, think about it, and we'll do some exercise tomorrow. Okay? Otherwise, you guys can pack up. Got about like 6-7 minutes.